Okay guys, before we go into an example, we first have to go over the kinds of frictional forces that can occur. So the first kind of frictional force that I want you guys to get acquainted with is static frictional force. And static frictional force occurs between two surfaces when the object itself is stationary. And what does that mean? Let me explain that quickly. So if I have a surface and we have a block over the surface, and that block is standing still, the type of friction that will occur is static friction. Okay, and if we have a force pulling in that direction over there, let's call it force applied. And the block is not moving, the block does not want to move yet. The thing that is holding that block back is static friction, and in this case, if the force goes that way to the left, the static friction will be pulling to the right. When you have static friction, in most cases, F net is equal to 0. What does that mean? Well, the F applied is not pulling the block to the left because the static friction is balancing that out, meaning that F net, which is equal to 0, is also F net equal to F applied plus Fs. And if that's the case, and F net is equal to 0, we can have 0 is equal to F applied plus force of friction. And if we take force of friction over, we get negative force of friction according to the F applied. So what does this tell us? That just means that the applied force is equal to the force of static friction, and that makes sense because if these two forces balance each other out, no movement occurs, it stays standing still. And the formula for calculating static friction is equal to mu s, which we've explained is the coefficient of static friction multiplied by the normal force. Let's go into the next kind of friction, and that is kinetic friction. So kinetic friction occurs when the object is moving. So a kinetic friction acts between surfaces when the object is moving. And this definition over here is what we find in the exam guidelines for kinetic friction. You guys need to know this really well. We have, and the formula for calculating kinetic friction is the force of friction is equal to mu k, which is the coefficient of kinetic friction, multiplied by the normal force. In many ways, it's identical to the static friction formula. The only thing that's changed is that the coefficient becomes mu k instead of mu s. Mu s would be for static friction. Let us go down into an example. So this is the first of our examples. It says over here, calculate the static friction of a stationary block with a mass of 5 kilograms. The kinetic coefficient of static friction is 0.67. And guys, whenever I do this, I like to always draw myself a diagram. If they don't give me a diagram, I draw my own diagram. So there's my block, there's my surface, and we know that this block weighs 5 kilograms. And they tell me here, they want us to calculate the static friction of a stationary block. So there's no applied force, they just want us to calculate the static friction. What is the formula? Static friction is equal to mu k multiplied by the normal force. Well, what is mu k? Excuse me, apologies. Now I'm saying mu k where it is actually mu s. So please don't make that mistake, guys. You get marks for the formula. So mu s multiplied by the normal. What is mu s? In this case, they tell us that it is 0.67. So we substitute 0.67, and we now have to multiply it by the normal force. But what is the normal force? Well, as you guys know, the normal force in this case over here, you guys can see that the normal force goes upwards and the force of weight goes downwards. So the normal force is equal to the weight force, so the force of gravity, and that's equal to mass multiplied by gravitational acceleration constant, therefore making the normal equal to mass multiplied by the gravitational constant. And let's substitute our values in there. So it's 5 kilograms multiplied by 9,8 meters per second squared. And what does that give us? That gives us 49 newtons. We now replace the 0,67 with 49 newtons. And what do we get? Just get the calculator out quickly. And that answer is 32,83 newtons. So our static friction in this case will be 32,83 newtons. Let's jump into a kinetic friction example. So it says here, calculate the kinetic friction of a block with a mass of 5 kilograms. Let's make our drawing. So there's my block, and that block weighs 5 kilograms on a surface, and the kinetic friction coefficient of the specific surface, so it's basically the roughness of the block, is 0,32. In many ways this is the same as calculating the static friction. The force of kinetic friction is equal to mu k multiplied by the normal force. But what is my mu k? 0,32. We're going to multiply that by the normal. But what is the normal? The normal in this case is the weight, and the weight is equal to mass multiplied by gravity. What is the mass? 5 kilograms. What is my gravity? 9,8 meters per second squared. I multiply those two together and I find that I get the same answer as previously, 49 newtons. I multiply my 49 newtons with 0,32. I'll make that substitution, and guys, the way we mark is as follows. So you get 1 mark for the correct formula, 1 mark for the substitution of both of these values, and another mark for the final answer. So we are going to go 0.32 multiplied by 49 newtons, and we find that our kinetic friction is 15,68 newtons. And I want you guys to notice that kinetic friction in most cases is always less than static friction, provided that the surface remains the same on the same surface. Very important. Right guys, let's go on. That would be all for today.